Hey guys, I'm Cyborg Sheep, and welcome to the Weekend Post. In this episode, we're going to continue on wiring my robot arm. First of all, I started out by asserting which pins on the DC jack corresponded to which pins on the DC plug. And just to make sure, I made a picture just to be sure which pins went to where. Then I put two wires into the connectors and secured it with glue. Then I wired it in the way I thought it would work and tested it out, only to find out that it doesn't go the way I want, move the way I want it to, and that I need to wire it differently. Okay, so at this point, dudes, I'm stuck. So how they've done it with the batteries is they've took two of these D-cell batteries and they've taken one end of the battery and fed it into the other end of the other battery. Essentially with the two pairs, what they've done is done this, and say this is a pair and this is a pair, and what they've done is if you take a lead off this end and off this end, essentially what you do is you get double the voltage. But what they've also done is they've taken a wire out from the center of these batteries. So essentially what they can do then is make a circuit out of this battery and make a circuit out of this battery, or the battery sets. And I thought what I could do is just do something like this, where I feed the red into the there. But I can't necessarily do what I thought I originally did, because if I put red here and black here, the power supply would short out and probably destroy itself, and I don't want that to happen. So I need to look for other alternatives for wiring the battery box. So if I can't connect the power supply in the classical fashion that I thought I would be able to, I need alternatives. And I have found something that might work. So, a great place to look for alternatives for me is Google, of course. And I really like this circuit right here. Basically what it does is it takes this triangle-y shaped component right here, and really what it is, it's a black square with metal pins coming out of it, and it takes two inputs, your voltage and ground, and it creates a virtual ground. And it also takes these two capacitors right here, and it says this can be a circuit if you connect your pins across here, and this can be a circuit. And if you can imagine this for a second, it essentially does this. And there you can see, there's our three pins that we wanted. So, this would more than likely work. So, now all I have to do is go and grab the parts for it. Okay, so, I did a little bit of thinking, and I think for our purposes, this circuit right here is going to be the best. Basically what it does is, it takes a capacitor right here and flips its polarity so that we can see this right here, this box thing, this is a timer chip. Basically it's like a computer that switches on and off really, really fast. And what it will do is, it'll charge up this capacitor, and this right here, this little triangle with the line in front of it, that's a diode. That basically doesn't allow current to go this way. Instead, it allows the current can only flow this way because the resistance going this way is theoretically infinite. So what we do instead is the current goes down here to charge up this, and then this right here can be a circuit, but instead of it going this way, it goes this way. So I went out and I got the parts for it. So, now all I have to do is build it. First, unpacking the parts. I opened everything up and made sure that the values were what they were supposed to be. Then, I soldered everything together. This was fairly uneventful as well. I did run into one problem though, that is soldering a green wire to one of the pins on the IC. I ended up having to flip the board over and solder it on the other side, and then soldering it where it had to go. Okay, so I'm outside right now. If you're wondering why I'm outside, because I don't entirely trust this circuit, I want to try it outside just in case anything blows up or has a tiny explosion. So I'm just gonna hook up voltage and ground. Okay, everything seems fine. Let's get the multimeter and test it. Hopefully, I should have Okay. Interesting. Alright, well let's try hooking this up to a motor. So if I say from ground to one end of the motor, and from voltage, positive voltage mind you, to the other end of the motor. It works, okay. Now if I disconnect you, nothing. Okay, so now that I know that everything works without anything blowing up, I've set it all up in such a way that it's just the way I'll have it hooked up when it's in normal use. So you can see I have my power cord plugged in there. Then if you look down here, I have the positive and negative going to the positive and negative of this circuit. I have the positive, negative, or positive, negative, and ground going to here, here, and here. And then I have basically this going to here, right here, and time to test it. So if I take my multimeter and I set it to here, and I put it across here and here, it's low, but it is negative. And then let's go from here to here. And yeah, okay, let's give this a try. So, there. Hello? Oh. Now, you see this right here, this pin? I think I might have found out why this isn't working as optimally as I would want it to be. This needs a ground potential, so let me real quick do that, and then we'll get back to business. Okay, I added a ground wire to this circuit, so it might work just a tiny bit better. So let's give this another try. Okay, so it's not, in adding that ground wire to that capacitor, it kind of actually made it worse. Now instead of getting up to 1 volt, it's like barely even getting up to 50 volts, or 50 millivolts, never mind that. So, I don't know. Well, it works. Not as well as I would hoped. Two things that I can see that are causing the problem here is, first of all, this component right here, this is a 10 nanofarad capacitor. Now, on the data sheet, it calls for a 1 nanofarad capacitor. So, I don't know about you, but I can clearly see that there's a problem there. And the problem is that because this has a bigger capacitance than what it calls for, this timer doesn't fire fast enough, which means this capacitor right here doesn't charge up often enough. Another problem might be that this timer right here, it's a LM555, where in the circuit it called for a NE555. So, how am I going to fix this, you may ask? Okay, well, I do have a couple of ideas to fix this. First of all, what I could do is replace this capacitor right here. Simply go to the store, buy the correct size capacitor, replace it, Bob's your auntie. Oh my goodness, it works. Another thing I could do is put in a higher input voltage here. So instead of 3 volts, I do say 5 volts. Now, I really don't want to do that because this robot arm is only rated for 3 volts. So if I put 5 volts into it, probably, I don't know, well, these motors here, they would wear faster. Also, this circuit right here may not work as good as it normally would have. So that means I'm left with one option. That one option is to use the negative and positive generated by this power supply. The only problem is that the voltage generated by it is 12 volts. And you can see the problem, 12 volts, 3 volts. I need to regulate it. Now, I could go online and buy voltage regulators that could regulate down to 3 volts, connect it up to the robot arm, works perfectly fine. But for now, I think I'm going to leave it at that. Anyways, guys, oh my god, dang it. How not to wire a robot arm. Hit that like button if you liked it, or hit the dislike button and suggest something else for me to do. Subscribe if you're new, and I'll see you during the next episode.